Okay, so now that we have our dummy variable set up in R, I want to briefly remind you how we're going to go about interpreting this fitted additive model. And remember, we're calling it an additive model because we are assuming that the effect does not differ based on the category. If we thought there were differing effects of receiving grants by rank, then we would include an interaction. And we're going to go over that in the next module. But for right now, we are just using an additive model in which we are adding the two dummy variables and their relationships together in our fitted line. So where X, remember, is the grant money in dollars, and D1 is going to be for assistant, and B3, right, or D2 is going to be for associate. And I'll give you a second to remind yourself what the baseline is. That'll be full. And in that case, right, since D1 and D2 will equal 0, then they basically just cancel out. And so the fitted line for a full professor would just be the beta, not the y-intercept, where x equals 0 for all of them. And then beta 1, which is just the relationship between grants and salary. Now, it need not necessarily be the case that full professor is our baseline. That's just what I've chosen, right? Because I constructed the dummy variables. And sometimes there's a more natural baseline, which can make an easier comparison. But I think that was the natural baseline, though there's nothing necessarily inherent in that choice. Now, I also want you to carefully think about exactly what each of the betas is truly estimating and how we can selectively choose our language to precisely match what we're estimating. So beta 2, which is about our first dummy variable, right, about assistant, is the average difference of salary, our y value, between assistant professors and our baseline category assistant or full professors, sorry. Then our beta 3, our second dummy, should be the average difference of salaries between our, I'll pause for a second for you to think, associate professors and our baseline, which is full professors. Then the difference between our beta 2 and beta 3 is the average difference of our salaries between associate professors and assistant professors, right? So remember, because we're using an additive model with no interactions, grants are assumed to have the same effect on salary for all levels of, I'll pause for dramatic effect, rank, right? So this model is going to give us three parallel lines. The only difference between these lines is going to be where they cross the y-intercept. So if that's the case, I want you to think about how are we going to test whether or not this is correct, right? We need to think about some sort of null hypothesis test to see if there truly is any difference between these different levels of rank, right? So let's think first how we would do that with regard to beta 3. So if we set up a null hypothesis such that there is no relationship between, and again, remember what beta 3 is, that's associate. So that's testing if the relationship for associate professor is different than the relationship for, always in comparison to the baseline, right, full professor. The same can be said for beta 2, but again, since that's our first dummy, that is with reference to assistant professors and testing whether or not they're different than the baseline, and that's the relationship that full professors have and salary. Now, we can also set up a null hypothesis test with regard to the difference between beta 3 and beta 2, and that's testing if the relationship for associate professors is different than the relationship for assistant professors. Now, we can also test whether they're equal to each other. And this is testing if rank has any effect on salary after accounting for grants at all. And we are going to do this by doing a partial f-test. So if you remember back to last time, right, we're going to look at a subset of variables, in this case, beta 2 and beta 3, to test whether or not they're equal to each other and whether or not they're equal to 0. And if we find evidence to reject the null hypothesis in this instance, that would suggest that one of these two variables has some effect or relationship on salary after accounting for grants.